Looking beyond petroleum. Today, we discuss what might be fueling business aircraft in the not-too-distant future. From the National Business Aviation Association, this is Flight Plan. I'm Rob Finfrock with your trusted source for business aviation news. Environmental sustainability is an important issue for all of us in business aviation, not only across our industry, but even in our daily lives. NBAA has been at the forefront of such efforts, perhaps most notably by promoting the use of sustainable aviation fuels derived in part from renewable feedstocks. SAF reduces carbon emissions not only directly from the aircraft, but in fact throughout the entire life cycle of the fuel, and it's available today. That said, there are also many exciting programs underway focused not on reducing carbon emissions from aircraft, but in fact eliminating such direct emissions completely through the use of alternative energy sources. It seems likely there will come a time when aircraft aren't powered by petroleum-based fuels, and that time might not be as far away as you may think. Val Miftakhov is founder and chief executive officer of Zero Avia, which is working to adapt hydrogen fuel cells to power commuter-class aircraft. Also joining us is Bai Aerospace founder and CEO George Bai, who is developing a line of electrically powered 2- and 4-seat light general aviation aircraft. George, your company has been conducting test flights of the E-Flyer 2 trainer for a few years now. Bring us up to speed, if you would, on where that program now stands.
You bet. The E-Flyer is our 2-seat electric aircraft, and the program has been underway for a number of years. This last year in particular, we've been flying with Rolls-Royce developmental motors and pre-production motor just this fall. We're very, very pleased with the progress. Battery management system, motor and motor controller are all working well together and demonstrating everything that we hoped with electric propulsion in aviation. We have had dozens of flights, but they've all been local area airport flights. In other words, we haven't gone cross country. All of the test flying has been power and speed pairs, the performance of the motor and matching or aligning the motor predicted performance with, of course, the engineering estimates, which aligned very, very well. That tells us that we're on track in our test program. It tells us that the performance of the airplane for range, endurance, and speed is going to equal or exceed what we had estimated previously.
Val, your company is currently testing its hydrogen fuel cell system on a modified Piper PA-46 Malibu, a type that's very familiar to business aviation. How is that effort progressing?
So for us, the primary motivation to focus on the technology as hydrogen fuel cells was the ability to deliver both range and the economics that we think will be attractive for the operators. So from the range perspective, just in the energy density of the energy storage components of the powertrain, the best batteries of today that you can actually procure and with reasonable cycle life would be at about a quarter of the energy density of a hydrogen fuel cell based powertrain, even if you use compressed gas as storage. If you use liquid hydrogen as storage, those numbers increase by 2-3x, further by 2-3x. So if you're after any reasonable sort of commercial aviation range, let's say 500 miles, which is our target for commercial launch in about 3 years, then utilizing hydrogen fuel cells makes a lot more sense to us. And then the second piece is the economics. If you look at the economics of producing hydrogen at scale, at location of consumption, so like the airport, for example, from local renewable power or local bio feedstocks, you're looking at the pricing of the fuel that puts you in a very competitive position relative to the jet fuel today. Obviously, with the powertrain being a hydrogen electric powertrain, so electric motors, power electronics, the reliability and sort of maintenance costs, reliability is higher and maintenance costs are quite a bit lower. So those two things made us go after the hydrogen fuel cell systems. And we have made quite a bit of progress over the last year and a half or so, during which we had active R&D program.
I'd imagine one of the issues to solve in using fuel cells like this is the matter of storing that hydrogen. How is ZeroAvia tackling the size and weight of such a storage system?
The hydrogen storage, and we are using compressed gas storage, is not really possible in the wings, especially in small aircraft, because the wings are too thin, and the storage containers for compressed gas like to be large cylinders. So even the fuel storage needs to be put outside of the airframe. So there is a good integration challenge there. And on top of that, the volume taken by the rest of the powertrain is generally higher today. So there is a bit of integration challenge, but it is solvable for the airframes starting at about 6-seat size. Right, so 6 and above is where it gets relatively easier. For the long distance flights, the larger tanks would go on top of the wings. So we have quite a bit of aerodynamic and stability analysis together with some of the pretty respected vendors in the space to specify the location of the tanks. And they would go on top of the wings at certain locations.
Another question that arises when discussing hydrogen is the matter of combustibility. But is that a difficult issue to resolve?
Yeah, it's actually pretty easy. Compressed hydrogen tanks are actually quite a bit safer than today's way to store aviation fuel, whether it's gasoline or jet fuel, basically stored in wet wing design. So relatively thin aluminum skin prevents the fuel from leaking, right? So any puncture of the skin off the wing typically results in a fuel leak. Compared to that, compressed hydrogen tanks that are designed to withstand high pressure from the inside, that makes them also very, very strong with respect to any external influences. You can look at the sort of safety statistics and examples from the automotive side, because there are about 15,000 hydrogen vehicles on the road today that are driving with those high pressure tanks every day in various situations. And they had to go through the crash testing, the burn testing, the penetration testing. And it's actually, some of those tests are quite spectacular. For penetration testing, for example, they fire high caliber guns. The tank is effectively a carbon fiber shell over a centimeter thick, right? So it's very, very hard to break it. In fact, it's probably the most structurally strong part of the aircraft.
Of course, many of these same challenges apply when storing energy in batteries as well. George, I understand your company is taking a slightly different tack here by using lithium-sulfur batteries rather than the more common lithium-ion composition. Why did you make that decision?
Lithium-sulfur is additional chemistry, battery cell chemistry, that is allowing us to look at a higher energy density. That is, more energy per unit weight in the battery cell. Lithium sulfur also holds the promise of greater safety, longer life, and cell, what we call a C rating, are the challenges with lithium sulfur. So cycle life and charging rates or discharging rates are the challenges with lithium sulfur cells. So we partnered with Oxys to understand these challenges, develop a roadmap of research and development to address them, and if successful, we'll introduce this new, safer, higher energy density cell chemistry to the market. Lithium sulfur takes the next step. The actual chemistry of the cell is beneficial, not just the manufacturing quality and the safety systems. So that allows us to take even a further journey down the roadmap of safety and quality, and more importantly, high energy density, which allows a greater operating range, greater operating endurance in the case of aircraft, and in particular, of course, for flight training or for air taxi or other uses of aircraft, lightweight and long range is very important.
George, your company and Val's are looking to different market segments for your respective offerings. By Aerospace is focusing primarily on the training market for now, but do you see applications for your approach in other areas, including within business aviation?
Indeed. Of course, training is critically important. The supply of pilots enables business aviation. Is vital. The resource of pilots being available is so important to commercial and business aviation. Beyond that, electric aviation has such a low operating cost threshold that new and unforeseen business opportunities emerge. And of course, among those that have been discussed are air taxi, kind of the expansion of the charter model to include a more application type of software on your phone opportunity, much like Uber or Lyft, but expanding that convenience with a local airport and opportunity to transport yourself at very low cost, very quietly and without CO2 in the urban area or short regional hops to get where you can't get today conveniently because of traffic or because of lack of regional aircraft availability, and perhaps most importantly, because of cost. The opportunity for that type of convenience electrically, electrically powered aircraft brings a whole new paradigm of not just convenience, but lower cost.
A question I'm sure you're asked quite often, George. How soon do you expect we'll see aircraft like your E-Flyer in the marketplace?
We see the access to market beginning in 2021, so just really around the corner, very soon. 2021, 2022, you'll see the 2 and the 4-seat E-Flyers be delivered to our initial customers. Very, very exciting time, very disruptive, but what a fantastic opportunity to reinvigorate general aviation and business aviation. Great partners, strategically, great market customers, all taking advantage of this new generation of electric aircraft.
ZeroAvia is looking at larger aircraft applications for its hydrogen fuel cell technology, up to around 20 seats with a target range of 500 miles. Val, I know you're focusing on commuter airlines, but that mission also sounds very similar to how many NBAA members are using turboprops and light jets today. Do you see opportunities in business aviation as well?
No, it's definitely one of the segments. We are more focused on the sort of scheduled service type missions because that's where you have the highest utilization of aircraft and the economics for us, because we need to have new fuel infrastructure in place. We need high utilization. So economics work best when you have high utilization. And that generally means scheduled service. But the technology can, of course, be used on similar sized aircraft or similar sized engine replacements for various missions. Like think about us as sort of PT6 size engine manufacturer, right? A replacement engine. So anything that powered by that size turbine is potentially in scope. So there's single engine aircraft like Pilatus PC-12, Cessna Caravans, that are definitely possible, as well as the twins 19-seater aircraft, or maybe a little bit smaller like King Air, Twin Otters, and so forth. Because if we bring the economics of the small aircraft closer to a larger aircraft, you can see some interesting things happening, right? Because people would love to fly more point to point and closer to their origin and destination. The problem today is the high cost of operating smaller aircraft for smaller operators. If we can help that, we think there is going to be some structural changes in how people fly and maybe how people drive long distances as well.
So Val, how do you see the market for alternatively fueled aircraft evolving from here?
One of the things that I think is interesting to look into as we compare different technologies for future aviation propulsion And mostly these are among the three, right? Turbine hybrids, battery electric, and hydrogen electric. It's interesting to look at sort of not only the let's say direct energy costs, but also some of the TBO costs of, let's say, battery powertrain, where you have the cycle limitations on the battery packs. If you take those into account, especially in the high utilization environments, the economics of the battery powertrain become a little bit more challenging. On the turbine hybrids, while they're great for very short distances where you use, for a majority of your energy supply, you use batteries and hopefully clean power, clean energy that goes into those batteries. For anything beyond, let's say, 50 miles, you are starting to use more and more of the fossil fuel. And at some point, there is no more benefit from the hybrid powertrain. So those things are sort of second order effects that are very interesting to look at as you compare different powertrain options.
George, your thoughts on what the future holds in this area?
When you consider the possibility of electric aviation and the five-fold reduction in operating expense, the convenience, the existing infrastructure, the runway, the security, the parking, safety, all of the things you need to have to almost immediately bring this new business opportunity to the market, to the customers, is really near at hand with conventional electric aircraft. I think what's interesting is what comes next. And if we ponder the possibility of going from 4-seat to 9-seat and the convenience that a larger aircraft will bring, it's not too far down the road before we'll see an all-electric aircraft providing the same kind of convenience and speed and range as we enjoy today with Pilatus or King Air or TBM or Piper Meridian type of aircraft. So we're very excited about the future. It's not too far down the road before we'll begin to see this kind of an airplane as well.
It sounds like we can expect to see further progress with these programs in the near future. For more information about the latest developments in alternative energy sources for business aircraft, visit the NBAA website at nbaa.org/environment. And that's the latest from the National Business Aviation Association. Remember, you can subscribe to all Flight Plan episodes at Apple Podcasts in the App Store, wherever you find your favorite podcasts, or download them from nbaa.org. I'm Rob Finfrock, and thanks for listening to Flight Plan.